Yeah, so this is, well, I would have wished to have it more prepared, but yeah, I've got some material which is work in progress and whatnot, but yeah, I'm going to talk about a little bit about application testing. So the basic premise is that, yeah, everyone likes work that works nice and works as intended and doesn't crash and everything. But the thing about it is that, well, writing good code and code that survives all situations and writing resilient code is not an easy task. So, I mean, there has to be some, well, it's not something that will come by itself, so you need to do something for it. And there's, for example, validation techniques that do help with ensuring that your code doesn't follow anti-patterns or does the thing as it is expected by the GLIF libraries and whatnot. But yeah. And then there is also, well, static analysis tools like Clang Analyzer and Cooperative if you want to go to privative solutions, and I'm sure of a few others. But the thing is that validation only gets you so far. There is a fair amount of false positives and also false negatives, like things that the static analysis will miss and it is actually bug, or things that static analysis will tell you it is buggy, but it is really not. And same with validation and linting and everything. It could catch many situations, but not all of them. So you need something in addition to this. It's not something that you can run a script on and get everything that might fail back to you. So that's why I'm more into actual tests and writing actual tests for the application, like actual code that runs through everything. And the most usual techniques for this would be unit tests, like trying to get a piece of functionality and trying to test it thoroughly. And then there's functional tests which are like a higher level. Yeah, they basically pick the application or the service or whatever you want to test more as in a real-life situation, and tries to test it on the outside and tries to make it behave, the tests behave as if it was a real situation. So the objectives would be evidently to maximize the code that is executed by the test suite, because yeah, that means that you are actually testing the code and actually testing that ideally you should be testing that it works correctly by for certain behavior and whatnot. But actually running the code in the test suite, it should be something to aim for, basically. It also helps you once you've got a proper enough test suite. You might have a way to identify regressions quickly and actually protect that your branch is going to work well, and spotting things before you merge them and whatnot. And to some extent, once you are really far into the testing coverage, you can actually identify unused ordered code, like things that you thought were covered in some situation, but you get to realize that they are actually there for no reason currently. So you can actually get to notice this unused code and remove it, which also leads to increased test coverage, so it's a win-win. For measuring this, you have the multiple tools. You usually compile with coverage support, and then you have several tools that are able to extract this information and to show you the code with some hints to show you which code is actually run by the test suite, which code is not, and whatnot. And there are 3 different flavors of test coverage, which usually these tools provide all at the same time, which could be the percentage of functions called, which is relatively easy to satisfy, as in, it only, as soon as you call a function, it will be given as good, so you've called it and validated somehow a little bit of its behavior. Then the next one in level of complexity will be the lines execute, which means that inside those functions you could go into these paths and see how many lines, if you have an if-else, and you could check which of both paths are you testing, or both of them, ideally, and whatnot. And then these well, I call it paths. It might not be the best term, but it would be the conditions that you have inside ifs. For example, if an if has if this and that, or that and that, then there is a combinatorial explosion of combinations that you ideally should check for all of them, because testing both paths in an if and else, it allows you to validate the code inside of that, but it does not allow you to validate whether all the conditions in that combination actually do something else wrong down the line, maybe, and whatnot. So, but this is actually really hard to satisfy, because on every while, on every for, on every if, and all of these conditions that you might have to test for all of the possible combinations, which is actually insane. Coverage has a fairly strict definition of good. I think this is relatively common, like this gcover and lcov, and also the GitLab UI all agree on these percentages, like less than 75 testing percentage is considered bad, and it shows as red. More than 75, it starts to be fine, but it's not still great. More than 90, it's considered good, more usually, but then I realized that there's a different shade of green, and it drives me bonkers in the libraries that I support, that I maintain, because I'm on some of them around between 90 and 90% testing coverage, and I realized that GitLab has a darker green for the actual good state, and I've not reached that yet. And actually, the thing with this is that I don't know if you know the Pareto principle, like, for example, like 20% of the available thing, of something available takes 80% of the resources, and things like that. It can apply to plenty of things, and this is one. Like getting to a point where testing is fine, or, well, no, not fine per this definition that I wrote here, like needs improvement, it could probably take just about as much time as it takes to take it to the other 90 or 95%. Because, the corners that you have left to test, they get harder to reach, and then you have to write more way more tests, you have to write way more specific tests, and then, yeah, the effort easily increases. So yeah, reaching to an actual fine or with coverage per these principles, it is quite a hard task even for libraries, which, I mean, library, I think, is a good sample for this kind of testing coverage and everything, because an API, a library API is basically already the code snippets, so you can call them and everything. So exercising the API is a way to get through most of things in a library. But in an application, yeah, there is additional challenges, definitely. And for these applications, yeah, the thing is that you have to test plenty of user interaction, like testing drag and drop of things, or testing input methods. If you implement something that you can type on and it's not a GTK entry, you should ideally test for internationalization and input methods and whatnot. And there's drag and drop, and there's people clicking, there's keyboard shortcuts, there's lots of user interaction driven through all kinds of devices that ideally you should be testing in applications. And but it is hard to automatize this for testing. So there must be something like I've been checking out of curiosity. I don't know if Control Center has coverage supporting CI. What is the percentage? 60. Yeah, that's what I expect more or less. I checked out of curiosity Nautilus, and it's also around 50, which is already pretty good for an application, but it shows that the unit tests only get you so far, because you have so much else to test other than the inner components that you can test individually. There should be ideally something that allows you to test something globally. And what would be ideally here, it's something that can run fully automated and headless, like something that you can plug on CI and have run on every merge request and test that nothing breaks and whatnot. It would ideally have these user interaction patterns thoroughly tested, and yeah, there's plenty of things plenty of corners that an application has, and it will be nice to test. And then to some extent maybe for individual widget testing and things like that, you could have reftests. This might be less useful for if you redesign an application, you might have to redo all the reftest samples and update all the images, the reference images. So comparing images still comes out as successful in CI. So this is reftests are maybe more useful for testing individual widgets or things like that, which Nautilus and settings and whatnot they have by the ton. And the prior art, there used to be Dogtail back in the day, like way long back in the day, and it was pretty entrenched on older principles. Like it used accessibility to identify widgets. Like it's something that you can do still nowadays, but it is not the best tool for that, because accessibility has got enough with with what is hot got to do in addition be a testing framework for applications. And it also used Xtest to simulate input, which might be the most canonical use for Xtest, because in other places it's used for a remote desktop and things like that. That it was not meant for, but also Xtest, it only got used so far. Like you could simulate keyboard and pointers to some extent, but you couldn't do any complex input like testing input methods or testing with another key map or testing. And it also used XBFB to run headlessly, and nowadays we are moving away from X11, so it could not be ideal to rely on legacy code to have your test framework running. And it ran externally to everything, to the app and the compositor, and it tried to modify it somehow, but it had quite a lot of limitations. But time went on. There's so much has changed since then, and now we have a different set of challenges. Like Wayland has made everything so much better, but except testing. So, but input testing is actually out of scope with Wayland protocols and whatnot. So it is more of a paradigm shift that we have to adapt to. But then we have to pick and integrate a compositor into CI. I think GTK is using Weston for the test suites. Yeah, I think so, yeah. And I don't know what others are doing. I think Nautilus was still using XWFB, which is the replacement, the spiritual successor of XBFB, but it's still X-Wayland, and it's still running X11, so it's not the best approach. I went back. And what a nice solution could look like. Ideally, I mean, we have our own platform, and we have our own environment, and we have our own compositor. So it would be nice that we could use Mutter for these things, and have Mutter be a dependency for the test suite in applications, and then running things headlessly over there. And it would be nice to run things in your own test suite so you can assert for your application behavior, but after inducing changes in the compositor. Like I press a key in the compositor, I expect that my entry has emitted the change signal, so I can assert for that. For this, I started, like, it's more of a proof of concept still, but I started working on the changes necessary for this combination of compositor and application inside a test suite. And I've been able to make Mutter coexist in the same process as an application, as a GTK application, by, well, basically changing the default main context that Mutter is running on. Mutter has already a number of other threads with their own main contexts, like the KMS thread and the input thread and whatnot. So it kind of made sense that its main thread also has an identity, and that we can swap it for this use case, for example. And ideally, it would be nice to have something to wrap in this framework in a nice package. And yeah, I wrote a small proof of concept And yeah, it requires this branch is still not merged, the Mutter branch. I think it could be merged fairly soon, hopefully. But by GNOME 50, I guess it will be there. This proof of concept does require that branch to be able to run something, but it is able to actually run a GTK application with a compositor within the same process. So the nice thing is that it is also introspectable, so it's not C specific. You can test if your application is written in Python. You could also kind of do Python tests and integrate this way. And yeah, this could be this is how things work currently in this proof of concept, like creating a kind of context that you start up before running GTK in it. So after that, the Wayland display is overridden, and you can run the application code within the compositor that has been created by this context. What is missing? Plenty still. Obviously, this is a proof of concept, but there is quite a number of things that they are already exercising in Mutter's test suite already. It would be nice to have input injection for mouse, well, for every kind of device that you might want. We don't have that much in Mutter, but it would be nice to have. That's on me, I guess. It would be nice to have a way to inject things from input methods, like being able to test that your application works correctly for Chinese or whatever. It would be nice to have an API to snapshot for reference images and so for comparison for reftests. It might be nice to have some scriptable input also, so that it's not like writing everything on code and like move mouse, assert that the mouse is on the widget, click mouse, assert that. It would be nice to have some more scriptability over there. And it would be also nice for certain user interaction patterns, like be able to replay EV, IMU, or live input recordings. So you can just ask for a recording and make a test case for something that was given by the user. So plenty missing. But once everything is in place and you have a good testing coverage, you can actually get quite a lot from it, because you can run a ASAN to find leaks. And yeah, if you have a pretty good coverage, you could have a good chance to find many leaks and to find quite some misbehavior that you might miss. And now you have something to have the CI do it for you. And you can also run msan for memory corruption, or tsan for thread race conditions and everything. So, but these tools kind of rely on on having pretty good coverage already, because they expect they run over the code you run in the test suite. So it's not like, unlike static analysis that looks at the code from far and tries to figure out things, this expects to run the code, basically. And this could also allow like other things to test, like we care quite more now about mobile, about now with Live Out Wait supporting mobile vertical layouts and whatnot. So we could test for that, and we could test for other kinds of form factors that might be there. And we could also look for other system integration, like running portals inside dbus run or something like that, dbus run session. So you could actually check that your application is integrating correctly with the system already in the test suite. That would be nice to have. And yeah, I don't have that much more material, so if you have any questions.
Thank you, Carlos. So yeah, we have 10 minutes for questions. Anyone watching from home, feel free to send the questions in the chat.
Yeah, this is actually interesting. I mean, something we were looking at, because I don't know if you've been seeing that at Garnacho we're developing these tools called YARF, which is basically a driver for testing, which allows to do to control a backend. At the moment, are just VMs or mirror, but I would actually like to do a Mutter backend, which allows basically to write tests using robot framework, which is the Nokia framework for testing. And I think we're already using for doing complete tests. So you run on VMs and basically run things there. But it would be nice to be able to make Mutter first citizen there, so we can actually run tests to that. And I think it will help to have already a base for writing tests for GNOME, where you only care about doing the actual test scripts. I think it's not covered by CLA, from what I can say. It can help at the moment. I mean, there are no checks on CI on that, so I think.
For how long?
But anyways, I mean, it's a thing we could actually be integrated very well with this. I think we could have some part of the, all the management of the tests themselves too.
Yeah, no, sounds something worth considering. And I mean, this is not to diminish either, like, how is it called, this thing where you get the needles and you can compare these images.
No, we only use...
yeah. So I think that, I mean, that there might be different stages where you want to test and you might catch different things. Like all testing, the more testing you have, the better. It's never enough. So yeah, it's like these things can actually coexist together, and I don't think this would take over. Yeah. Yeah, no, but it makes sense. Yeah.
Hello. I'm up here.
Hi.
Yeah, I'm really happy to see more testing tools. I spent a while looking at OpenQA, as you know, which has good things and bad things. It's very heavyweight. It's probably the bad thing. It's very powerful. That's the good thing. But the main thing I learned is that what we really lack is a way to define these tests that's independent of any tool. Because the dream would be if you could migrate from one tool to another, right? Like, if you have a set of screenshots, like reference screenshots, and you can click here and stuff, having a standard format for that would be really nice.
Definitely. Yeah, that's why I was trying to push for reftests being used for individual widgets and things like that, because it becomes easier to test a single thing than the whole application. And if you redesign or the CSS changes slightly or there's a different pixel in the shadow, that's basically worthless to test or to spend too much time on. So
yeah. What do you think about fuzzy image matching as a feature?
Yeah, that might be a possible way, but then you get into false positives and false negatives, and yeah, it's got pros and cons, I guess.
Yeah. Okay, thanks.
Any other questions in the room? Okay, I think that's it. So some people are writing in the chat, great talk. Carlos, thanks. And yeah, thank you so much.
Thank you.